Some of the absolute strangest, most self-destructive behaviors we see in the animal kingdom, well, they might not be choices at all. They could be the work of a single, hidden puppet master, pulling the strings from deep inside the brain. And today, we're going to uncover exactly how this tiny manipulator works.
I mean, think about it. It makes zero sense. A rat, whose every instinct should be screaming "run," suddenly loses all its natural fear. It even becomes drawn to the smell of its number one predator. That's not just risky, that's basically a suicide mission. So what could possibly cause an animal to act so completely against its own survival?
And it's not just rats. Over in Yellowstone National Park, researchers started noticing something really bizarre. Some wolves were suddenly becoming these hyper-aggressive risk-takers, leaving their packs, challenging alphas, and becoming leaders at a rate that just completely defied the odds. What on earth could connect a fearless rat to an alpha wolf?
Well, the answer to both is the same, and it is wild. It's a single-celled parasite, an organism so sophisticated it has literally evolved the power to hijack the brain of its host, rewriting their most basic instincts for its own benefit.
Okay, but here is the part that should really get your attention. This parasite, Toxoplasma Gondii, isn't hiding in some remote jungle. No, it's estimated to be living right now inside the brains of 1 out of every 3 humans on the planet, which forces us to ask a pretty serious question. If it can do all that to a rat or a wolf, what is it doing to us?
So, to really understand its influence, you first have to understand its incredibly clever strategy for survival. Its entire existence is built around one single, relentless goal.
It all starts and ends with a cat. See, the parasite can only reproduce sexually inside a cat's gut. From there, millions of tiny, tough little eggs get shed into the environment through its feces. Then, any other warm-blooded animal, a mouse, a bird, a human, accidentally ingests one, and they become what's called an intermediate host. The parasite then forms these little dormant cysts in their brain and muscles and just waits. It waits for that host to be eaten by a cat so it can complete its life cycle. That's the whole game. And it explains why it messes with behavior. It's all about making its host an easier meal for a feline. Now, once it's inside an intermediate host, like us, the parasite goes into stealth mode. It changes into this slow-dividing form, creating tiny, microscopic cysts in our brain and muscle tissue. And these aren't just passing through. They can settle in and stay there dormant for our entire lives. So, if this thing is setting up shop in our brains for life, that brings us to the biggest question of all, right? What is it actually doing up there? Well, the answer is a whole lot more complicated and, frankly, a whole lot weirder than we ever thought. It looks like the parasite has this clever three-pronged attack to mess with its host. First, get this, it has its own genes to make dopamine precursors. It can directly mess with the brain's reward and motivation system. Second, the cysts don't just land anywhere. They tend to cluster in the amygdala. That's kind of the brain's fear and emotion headquarters. And third, studies show the infection is linked to higher testosterone levels in both men and women, which, as you know, has a big impact on things like boldness and taking risks. And all this brain hacking leads to some really specific and honestly kind of strange personality shifts that are different depending on gender. Long-term studies have found that infected men often become more suspicious, more jealous, and a bit less concerned with following rules. Infected women, though, they tend to become more warm-hearted, more outgoing, and more conscientious. We don't totally know why there's a difference, but it's a finding that keeps popping up. But the changes aren't just in your head. The parasite can actually impact our physical abilities too. One of the most documented effects is that it slightly slows down our reaction times. Now, that might not sound like a big deal, but that tiny delay has a huge real-world consequence. Infected people are 2.65 times more likely to get into a car crash. But here's where the story takes a fascinating twist. That same shift in risk perception is a total double-edged sword. So yeah, it's a liability when you're behind the wheel, but it might just be an asset in the boardroom. Believe it or not, studies have shown that people with a latent infection are way more likely to major in business and are 1.8 times more likely to start their own company. It seems like the parasite literally lowers the fear of failure.
So we've covered personality quirks and risk-taking, but the parasite's influence goes much, much deeper. There is a growing and very serious body of evidence linking it to some severe psychiatric disorders.
The numbers here are pretty staggering. A person with a latent T. Gondii infection is 2.73 times more likely to also have schizophrenia.
The connection to bipolar disorder is also really significant. Now, to be clear, this correlation doesn't prove the parasite causes these conditions, but it is now seen as a major environmental risk factor, something that could potentially trigger or worsen these illnesses in people who are already vulnerable.
And what's truly mind-boggling is that the parasite's influence can start before we're even born. Research shows that if a mother has a high level of infection during her pregnancy, her child has a 2.61 times higher risk of developing schizophrenia as an adult. This suggests the parasite might actually be interfering with how the brain develops in the womb.
So this parasite doesn't just mess with individual hosts. Its effects actually ripple outward, reshaping entire ecosystems by fundamentally changing how predators and prey interact. Let's circle back to those wolves in Yellowstone. A massive study spanning almost 27 years found that infected wolves, who probably picked up the parasite from cougars, became incredibly bold. They were 11 times more likely to just up and leave their home pack, and an absolutely astounding 46 times more likely to become a pack leader. A tiny parasite is literally helping to decide who runs the pack.
And when this parasite gets into the ocean, the consequences can be just devastating. In Hawaii, runoff from the land can wash cat feces containing the parasite's eggs into the sea. And out there, it's become a leading cause of death for the critically endangered Hawaiian monk seal. For them, the infection is almost always a death sentence.
It's a similar story off the coast of California, where infected sea otters are nearly 4 times more likely to be killed by sharks. Now, this isn't because they're suddenly attracted to sharks, it's because the parasite seems to mess with their motor skills and reaction times, which just makes them much easier for a shark to catch.
For decades, scientists thought that once you had this chronic infection, you were stuck with it for life. Those little dormant cysts in the brain were like unbreakable fortresses. But now, that is finally beginning to change.
A huge recent breakthrough finally figured out how the parasite causes so much trouble neurologically. It turns out it messes up the communication between brain cells by causing a buildup of a chemical messenger called glutamate. This buildup basically overexcites the brain's circuits, leading to cell damage and all sorts of altered connections.
And understanding that is leading to all sorts of new ways to fight back. For the first time, scientists have real targets. They found the master switch proteins the parasite uses to go dormant, which could lead to drugs that prevent the chronic infection from ever taking hold. They've found other drugs that can actually kill the cysts that are already there. They're even figuring out how to starve the parasite by attacking its metabolism. A true cure for chronic toxoplasmosis? It actually seems possible now.
But taking on a parasite this widespread, this complex, it's not a job for just one field of science. As this quote says, the only way forward is for everyone to work together. We need veterinarians, wildlife biologists, and psychiatrists all at the same table, trying to understand and combat its influence across every species it touches, including our own.
It all leaves you with one final, pretty unsettling thought. If a single-celled organism can quietly influence our personality, our ambition, our tolerance for risk, and even our mental health, well, how many of the choices we make every day are truly 100% our own?